Alright, so I'm going to show you how to break a vector up into components. I'll take it nice and simple, nice and slow, so that you can pause it, you can go back, and just do whatever you have to do to really get this. So, first of all, make sure that you understand what we're using here. I have a theta. Theta just means, it just stands for the angle. It's like using x and plugging in for that. Instead, we're going to use theta. Um, the other things that we're going to be using is SOHCAHTOA. Remember that SO is sine of an angle is equal to the opposite side divided by the hypotenuse. Cosine of an angle is equal to the adjacent side divided by the hypotenuse. And tangent of an angle is equal to the opposite side of that angle divided by the adjacent side. It's really crucial that you remember this. It's just one of those things that unfortunately you have to remember. Um, So from there, I'm just going to make up a problem real quick so we can do this together. Um, so I have a vector here. Remember, a vector can represent anything with magnitude and direction. In this case, we'll have it represent a v initial. In this case, we'll make it 20 meters per second. So some object is traveling 20 meters per second initially at an angle of 10 degrees. So that's not a very big angle. So the first thing that you're going to want to do when attacking any of these types of problems, if you haven't already, write out what you're given. So if you're just given it in a word problem, you might want to draw this first, right? Draw a vector and draw the angle just like I did here. Then you want to break it down into components. So you know that this thing's going up and to the right. So you're going to need to draw an arrow to the right and draw an arrow up. These are also vectors. These are components of this vector, to be more specific. This is the y component, and this is the x component. What that means is that there's some component of this 20 meters per second that's going to the right, and there's some component that's going up. When you throw something, you're partially throwing it to the right, and you're partially throwing it up. And combined, it makes this vector here, the initial velocity. So from here, we need to start using our trig rules. Sine is opposite over hypotenuse. This is the opposite side. This is the adjacent side, and this is the hypotenuse side. This is always the hypotenuse, and we know that because, first of all, it's opposite the side of the right angle. Also, it's the longest side, and it's the diagonal. That's usually how we figure that out. These are the sides here. So this is the hypotenuse. This is the angle here, so we know that this is adjacent. So this is right next to it. Adjacent means next to. And this one's opposite, just like this. See how it goes opposite like that? So if we want to find, we can pick either one that you want to start with. Let's start with v initial y, because we've been starting with the x in class. With y, all you have to do is find out which one has the opposite and the hypotenuse. When you come up to here to SOHCAHTOA, you see that this has hypotenuse and opposite sides in it. So what we can do from there is write this out. Sine of theta is equal to the opposite side over the hypotenuse. So now we plug in what we know from here. The sine of some angle is going to be equal to the opposite, which is v initial y, divided by the v initial, which is the hypotenuse there. See how that's v initial? So this is kind of a general form. On the paper that I gave you, you might notice that you might see it written something like this. Just watch. So if we multiply both sides by v initial, that cancels that out. And so you're left with, if I rewrite this and bring this, just switch the sides, just so I prefer it like that. V initial y is equal to v initial times sine of theta. Now you see this is more like what you saw on your paper. More specifically, it looks like this, where the only thing that changes is the r instead of the v initial. So now what I'm going to do is, now that I have this equation, you just go ahead and plug and chug. So we have v initial y is what we're looking for. So that's equal to 20 meters per second times the sine of 10 degrees. Now, here's the part that some people might get confused on. Now I have this calculator, and in a second I can go ahead and grab the other one, just so we know how to use it. I'm going to turn it on. When you go into your calculator, you're going to have sine, cosine, and tangent buttons somewhere. They got to be somewhere. In this case, we have sine, cosine, and tangent. I'm going to show you how to plug this in into your calculator. So all you have to do is 20. You can hit the multiply sign, or you can leave it. Either way, it will multiply on its own. I have to do second sine. My sine is right there, times 10 degrees. Now, this will work, and it'll work if you have it in degree mode or radian mode. You'll get two separate answers. If you got 3.47, good, that's the right answer. But, well, here, let me show you. So in mode, right here, for me, that's where I go in to change it to degree or radian. Now, don't do this. I'm just going to show you that you'll get a different answer. You want it to be in degree, but don't do this. I'm going to put this in radian mode for a second. Now, look what happens when I do the same thing, but in radian mode. I get negative 10.88. So it's not that it'll give you an undefined answer. You will get an answer if you're in radian mode. It's just going to be the wrong answer. So that's why we need to make sure we press mode, and we are in degree mode. So now I get 3.47. So that's the correct answer. So I'm just going to write that in, 3.47 meters per second. And that's going to be the V initial and the Y. That's right, we started with the Y. So now, to go ahead and finish up, all we have to do is the V initial in the X direction. And it turns out it's just going to be the same thing, V initial cosine theta. All you have to do is switch it from sine to cosine. So then we plug and chug again, 20 times sine of 10. And again, to show you how to do that in the calculator, we have 20 times sine 10, cosine. Whoops. There we go. And you get 19.7, we'll say. So 19.7 meters per second. Oops, I put squared. It's not supposed to be squared. Alright, so this is your X component. This is your Y component. And when you plug it into this guy with the X and the Y, your V initials, this is going to be the X one, which is 19.7. This is going to be the Y, which is 3.47. Alright, and then from there we would proceed as normal with our projectile problems. Alright, so what I'm going to do from here is I'm actually going to go ahead and grab another calculator just to show you where some things are. So if you have a different calculator from this, you want to stick around for the rest of the video, I'm going to go grab that calculator now. Here I have a TI 30X2S. I'm just going to show you how to solve the problem on this one because I think that more students would have this guy. First of all, notice that the sine, the cosine, and the tangent are actually right here. I don't know if you can see them very well. It's auto-focusing. The other thing that I want you to notice is right in this corner here, you can see a little DEG. That means it's in degree mode. So that's good. But in case it didn't say that, you would want to find the mode button on your calculator. And currently I'm having a problem finding it, but we'll figure it out. What the heck? Oh, I see. Oh, okay. Float. Okay, so this is where you're going to want to find the degree, radian, and gradient. That's what the DRG stands for. All you want to do is press it, and right now it's in degree. If you were in radians, this is what it would look like. You would see the RAD in there. That's not good. You don't want to be in that, so press it again and go back to degree. All calculators have some kind of mode button or degree, radian, gradient button, basically something that lets you change it from degree mode to radian to gradient. We want to work in degree. Anyway, now that you have that set up, you're just going to have, let's try punching this in so you can see how it works. 20 sine 10 degrees. You just type in 20. In this case, just press sine here and then 10 and you get 3.47, and that's what you should get. That's what we got before. All right, so that's how you use this calculator. In this case, this is the TI-34-2. All of the trig is in, like you notice there's no sine, cosine, tangent on here. So what we're going to have to do is go to trig. Notice the trig is a second right above my thumb there. So you press second trig, and well, first you want to turn it on. Second trig, and now you'll see that there's sine, sine inverse, and you just want to scroll with this button. Cosine, cosine inverse, tan, tan inverse. So you pick the one that you want. If you keep pressing right, it keeps scrolling. So in this case, we'll choose sine. So sine of 10 degrees times 20. And you get 3.47. So luckily this one's in degree mode, although I believe it's at the same part, so you have to do second. See how it says DR, that's probably degree in radians. So this one doesn't have gradient, so it's either degree or radian, so it's already put in degree mode, so we're good. Alright, so that ends my vector components tutorial. Hopefully that helped, and see you tomorrow when we definitely have school. Thanks, Obama.